Hello there! Welcome to this video 10-2 on writing and solving equations involving trigonometric ratios. In this video we're going to go ahead and continue to use sine, cosine, and tangent and the SOHCAHTOA acronym, which is right here behind me, and we're going to go ahead and look to solve some equations. So let's go ahead and get started. Our objective: find sine, cosine, and tangent to find a side or an angle of a right triangle. Now, a couple of things I want to review with you for prior knowledge are how to solve equations when we have denominators. Remember, in order to solve an equation where you have a denominator, you just need to multiply by whatever is in the denominator. So what I do to one side, I have to do to the other. So these will cancel. And I now have 4 times 2x plus 3 over 5 is equal to x. And again, I need to cancel out the denominator on this side, so I multiply both sides by 5, right? I'm undoing division, so we multiply. So we cancel here, and I get this equation. So 4 times 2x plus 3 is equal to 5x, okay? That's as far as I want to go with that example. The rest of it doesn't really apply to this lesson. The next prior knowledge I want to talk about is rounding. Rounding is important in this lesson, and for angles we will round to the nearest tenth. So the nearest tenth is this location. And if I want to round there, you have to look next door. Am I going to round that up or down? Well, the number next door is 8. Remember, 5 or more, up the score. 4 or less, let it rest. So it is more. So this is approximately 13.7. All right, B. Again, I need to round to the nearest tenth, so I'm going to look next door. 2, is that 5 or more or 4 or less? 4 or less, so this is approximately 5.5. C can get a little tricky. C is tricky because I'm rounding to the nearest tenths, and I'm going to look next door. 9 is obviously 5 or more, so I'm going to up the score on the 9, and the next value would be a 0. Well, if I bump up the 0 in the tenths place, I also have to bump up the ones place. So we go from 6.99 to 7.0. So I'm going to up it, the 9 to a 0, but I also have to bump the 6 to a 7. All right, go ahead, try D really quickly. Pause me, give D a go. All right, hopefully you tried D. Your answer should have been approximately 3.8. 3.8. Okay, last prior knowledge that I want to cover with you is how to use a calculator to find these values. So you're going to find each trig ratio, and they say round to 3 decimal places. Round to 3 decimal places. So we're going to go ahead and compute using a calculator, and here is an image of a TI-30. And our trig values are right here. You can see sine, cosine, and tangent. So those are those values there. And then also buttons we'll use later on are the inverses, which are right above it. You'll see in blue, sine inverse, cosine inverse, tan inverse. And how we utilize those functions, anytime you're going to access the blue writing, you have to hit the secondary button, which is here. So you hit second, and then that button, and it will utilize that function that's written in blue. So that's kind of how you use the TI-30. I don't have an online program to utilize the TI-30, so I'll just show you the buttons there, but I am going to use Desmos. And Desmos has a great scientific calculator underneath here where it says Math Tools Scientific Calculator. You can use the graphing calculator, but I mean, I don't need to graph, so I'm going to kind of ignore that. And on the scientific calculator, you can see here, here's sine, here's cosine, here's tangent, and then other functions underneath this tab. You can see the inverse buttons here. So, okay, the first example we wanted to do was sine of 32 degrees, 32 degrees. And then you'll see the answer here. If your answer is not this answer, 0.5299, you need to make sure that you're in degrees and not in radians. And how you tell this on your calculator, one here, it says DEG, so it's in degrees. And then on your calculator, you can see here in the corner, it'll say rad, or it will say degrees, okay? And how to kind of switch from that is you'll click this button here, the DRG, and you will go ahead and kind of switch out of that. Okay, so let me go ahead and write down the answer that I want, 0.5299. So I need to go ahead and round this. So this is approximately 0.5299. If I'm going to up the 9, it's going to become 0.530. Okay, cosine of 65. So I'm going to clear this. I'm going to go ahead and punch in the cosine, and then 65. On your guys' calculators, you can close this parentheses. I would definitely close the parentheses if you are multiplying with something else. So you want to go ahead and do that. So I closed it, and we get 0.422. I'm rounding 3 decimal places, so I look next door. The 6 is more than 5, so I'm going to up it, so 0.423. So approximately 0.423. Okay, 3 times tangent of 50. So let me go ahead and bring this up. Okay, so say 3 times tangent of 50. Tangent of 50. And we get 3.575. 2 is less than 4, so 3.575. Okay, and then here, 15 divided by cosine of 46 degrees. So 15 divided by cosine of 46. So cosine of 46. I'm going to close there, especially when I'm dividing. I want to make sure I close that. And we get 21.593. 21.593. All right, so that was kind of just some prior knowledge on how to use your calculator to get trig values and how to round. Okay, so let's go ahead and dive into some problems. All right, first, the concept. We are going to go ahead and solve equations utilizing a trigonometric ratio. And remember that the trig ratio involves the 2 sides of a right triangle. So the 3 primary trigonometric ratios are sine, cosine, and tangent. So sine of an angle is the side opposite over hypotenuse. Cosine of an angle is the side adjacent over hypotenuse. And tangent of an angle is the side opposite over the adjacent. And again, we can use the acronym SOHCAHTOA. So here is the first example. And part A says write an equation to find x using sine, cosine, or tangent. All they want you to do is just write an equation. Okay, so I am given this angle here, angle 70. And again, I'm going to put this star, label the sides. So I need to find the side that's opposite. And I'm given hypotenuse. Okay, so what trig function involves opposite and hypotenuse? If you forget, again, right, so the TOA. Okay, and obviously the side that's opposite and hypotenuse, that's going to be sine. So sine of my angle, 70 degrees, sine of 70 is equal to opposite, which is x, over hypotenuse. That's 16. That's part A. Done. Okay, there we go. All right, B, now they want us to find the value of x, round to the nearest tenth if necessary. So I need to solve for x. Okay, well, how do we undo division? I want to get x by itself. So I'm going to undo division. I'm going to multiply by 16 on each side. Okay, this is B. So now I have 16 times sine of 70 is equal to x. All right, there's the exact value, and we want to go ahead and approximate this. So I'm going to use my calculator. We got 16 times sine of 70. sine of 70. So 15 point, and they want us to round to the 10th, so I'm going to look at the 3, I'm going to let it rest. So 15.0. 15.0. So x is approximately 15.0. And I include the location just so it's clear I rounded to that nearest 10th. Okay? All right. There's example 1. Example number 2. Again, write an equation to find x using sine, cosine, or tangent. So which trig function am I going to use? Well, it depends upon what sides you're given. So here's the angle that I'm working with, 41 degrees. Okay? So from this angle, this side is opposite, this side is hypotenuse, and this side is adjacent. So I obviously want to use hypotenuse because that has the x, and then I want to use the side that's adjacent because it is 13. I'm given it. I don't know anything about the side opposite. I'm not going to use that. So what trig function involves adjacent and hypotenuse? And again, if you forgot, write down SOHCAHTOA. Okay, well, the side that's adjacent and the side that's hypotenuse, that's going to be cosine, A over H. Okay, so here's part A. Cosine of 41 degrees is equal to 13 over x. And that's part A. We're done. B, they want us to go ahead and find the value of x. So you'll notice x is in the denominator. Well, how do we undo division? Multiplication, very good. So I'm going to multiply both sides by x, and we get x times cosine of 41 is equal to 13. Well, I haven't solved for x. Now I want x by itself. So how do we undo multiplication? Because that's what's going on, right? Aren't I multiplying x with cosine of 41? So how do we undo multiplication? With division. So now I'm dividing by cosine of 41. Divide by cosine of 41. And we get x is equal to 13 over cosine 41. Okay, and we can use our calculator. Let's go ahead and compute this. So, what do we got? 13 divided by cosine of 41. So 17.22 is going to become 17.2. So this is approximately 17.2. And there's our answer for B. All right. Okay. All right. Remember, make sure you label the sides based upon the angle that you're given. If I was using angle M up here, my labels would be different, right? So you need to make sure you label because that's gonna change what side you're working with. And then we just use our acronym, SOHCAHTOA. Don't be afraid to write down SOHCAHTOA on the problem just to help you on your paper, just to help you kind of remember or look at it. Here is, another example. I thought it was a practice problem. Here we go. Okay, so I am given angle 54, which is here. And then this side is hypotenuse, and I'm given opposite, and I'm looking to find adjacent. So my equation for part A, adjacent and hypotenuse, again, here's SOHCAHTOA. Opposite and adjacent is tangent. So tangent of the angle always goes inside the trig function, is equal to opposite, that's 70, over adjacent, which is x. Okay, B, now I need to go ahead and solve this. So I'm going to multiply both sides by x. And we have x times tangent of 54 is equal to 70. Well, x isn't by itself, so I now need to go ahead and undo multiplication. So I'm going to divide by tangent of 54. And so we get x is equal to 70 over tangent of 54. And I got to go ahead and compute this. So 70. Okay, and we get 50 point, it looks like 9, 50.9. All right, there you go. That's how you write an equation and solve the equation using trigonometric functions. I do have a practice problem for you here. Go ahead, please pause the video, and then I'll show you the equation first, and then you can pause it again and solve it if you want that double step. Okay, pause the video. All right, hopefully you pause the video. Here is the solution. So this is involving adjacent and hypotenuse. So this is cosine. Cosine of 72 is equal to x over 12. That's part A. All right, if you have not solved it, go ahead, pause the video now and solve it. Here are the solutions. So this is approximately 3.7. So x, this side length, is approximately 3.7 units. All right, now we're going to go ahead and we are going to solve for angles. Now, in general, if you know the lengths of two sides of a right triangle, you can use the corresponding inverse trigonometric functions to find an acute angle. This is expressed mathematically in the statements below. So if I want to go ahead and find an angle, angle A, and I have the side that's opposite and hypotenuse, I can use the inverse sine function of opposite and hypotenuse to find that angle. And that makes sense. Remember, inverses undo each other, right? So if taking a trig function of an angle tells me the ratio of the sides, well, doing the opposite, right, to both sides, so sine inverse of this side will tell me the angle. Same for cosine. If I want an angle and I have information about the side adjacent and hypotenuse, if I take the inverse cosine of that ratio, I will get the angle. And then for tangent, I can find the angle if I take tan inverse of a ratio of the side opposite and adjacent. Okay, so these are very, very intuitive. You use the inverse, and maybe write this down. Use inverse trig to find angles. You find the angles using inverse trig. Okay, and again, this is just a note on how we read this. When we have this power of -1, it means inverse. So sine inverse. All right, let's go ahead and look at an example. So here's an example. All right, A, they say write an equation to find x using sine, cosine, and tangent. All right, well, if I have this angle, or I want to find this angle, I am given information about the side opposite. I'll write this in red. This is the side opposite. And this is the hypotenuse. Again, adjacent, I don't have any information about the side adjacent. So I'm not going to use any trig function involving adjacent. Okay, so my equation, opposite over hypotenuse, that is sine. So here is part A. Sine of x is equal to, the side opposite is 31, the side that's hypotenuse is 53. So there's your equation. There's part A. There's your equation to find it. Now what we want to do is we want to go ahead and solve this. So B, I want to solve this. Well, again, I want to undo the sine function. Don't I want to solve for x? I want to get x by itself. So how do I undo a sine? The sine function? Well, you undo it with its inverse. So I'm going to take sine inverse of each side. Okay, and that kind of looks what it looks like. And I am going to cancel these. So these cancel. And we get x is equal to sine inverse of 31 over 53. Now, some people can jump straight to this equation. They can jump straight there. I know I want to solve for an angle. I know I'm given opposite and hypotenuse. So the angle is the inverse sine function of 31 over 15. Okay? So you can do that, and then we're going to go to our calculators. Again, on your guys' calculator, to access the inverse trig, you need to hit the second button, second, and then the appropriate trig function. Okay? So that you should see sine inverse on your calculator. I'm going to go ahead and use Desmos since I don't have a way of showing you with the TI-30. So I have my function value. Okay, so sine inverse of, it looks like 31 divided by 53. Okay, and we're in degrees. Again, double check, make sure you're in degrees. Your screen should say DEG. If it says RAD, you want to hit that DRG button here and make sure you go over to DEG and hit enter. So again, your answer should be 35.796, and I think they want us to round to the nearest whole degree. They do right here, round to the nearest degree. So that's the ones place, nearest whole degree. Okay, so I want to round to this position, looking next door, that's 5 or more. So this is going to be approximately 36 degrees. Approximately 36 degrees. And that looks terrible. What's going on? Approximately 36 degrees. Okay, so we have solved for x. All right. Oh, uh-oh. Oh no, okay, fixed it. Here you go, next example. All right, write an equation to find x using sine, cosine, or tangent. So A, I am given this angle. I have given information on opposite and on adjacent side. Nothing involving hypotenuse, no information, and I'm not trying to find it. So I'm not going to use any function involving hypotenuse. So this is going to be opposite of hypotenuse, that's tangent. So tangent of x is equal to opposite, that's 36 over 25. Now I want to go ahead and solve for x, part B. So what I'm going to do is I'm going to take the inverse of the trig function, so tan inverse of the side, that's 36 over 25. And then I'm going to go ahead and I'm going to compute that. This is not just me. I don't know what's going on here. I can't write. There we go. Now it's nice. Something funny's going on with my computer. Okay, let's erase this. Tan inverse of 36 divided by 25. 55.222, so just 55 degrees. Okay. These aren't too bad, yeah? Yeah. All right, last example I got for you. All right, write an equation. Okay, here's x. I am given the side adjacent and hypotenuse. So adjacent and hypotenuse. So cosine of x is equal to adjacent over hypotenuse. There we go. Okay, B. We want to go ahead and solve. I want to undo the cosine. I just want x by itself. So how do I undo a trig function? Well, with its inverse, cosine inverse. Cosine inverse. Okay, 7 over 19. Plugging this into our calculadora. 7 divided by 19. And we get 68. All right, the 3 we're going to let it rest. So 68 degrees. All right. Look at you guys go. Okay. Here is a practice one. Please pause the video. Try this example. I'll show the equation first and then the solution. All right, hopefully you went ahead and wrote the equation. The equation, we're given opposite and hypotenuse. I don't have any information about adjacent. So this is sine of x is equal to 7 over 14. Okay, pause the video. If you haven't solved that, go ahead and solve. All right, and then B, here's the solution. X is equal to sine inverse of 7 over 14, or 1/2. It would give you the same value, and that would be 30 degrees. All right, next example. Please pause the video. Try this one. Okay, here is part A. Part A, I need to go ahead and write an equation. Notice, man, what the heck, Schwarberg? You changed it up on us. I did. I gave you the angle now, and we're given information on opposite, and I need to find the side that is adjacent. So, okay, what's the trig function? Well, opposite over adjacent is tangent. So tangent of 45 degrees is 11 over x. And then go ahead, pause the video if you haven't solved that yet. Okay, here's the solution. I need to multiply both sides by x first. So I get x times tan of 45 is equal to 11, right? I'm undoing multiplication or division. So I multiply both sides by x. All right, and now to isolate x, again, I need to undo multiplication with division. So x is equal to 11 over tan of 45. Which is 11. Okay. Here we go, closure. In the diagram below, the measurement of angle B is 35 degrees, and side AC, again, AC is the side that connects point A and C, it's 12. Which equation can be used to find side AB? Pause the video, try this one. Okay, hopefully you pause this. AB, here's A, here's B, that's this side. So that is, you're finding the hypotenuse, okay? Well, if you're given opposite and you want to find hypotenuse, that's sine function. So sine of 35 degrees is equal to 12 over x. Now notice that's not on there. I need to go ahead and shuffle this. So x times sine of 35 is equal to 12, and x is equal to 12 over sine of 35. I don't know what's up with my... Okay, there we go. All right, so it looks like D is our answer, D. All right. Hope you enjoyed this video on how to write equations involving trig functions and how to solve them. Please give me a like, subscribe. Catch you next time. Peace out.